All right, now this problem is just a slightly more complicated version of the other displacement problem that we did. Now, for this one, we're going to be walking 8.1 kilometers in a direction of 55.4 degrees west of south. And then from there, we're going to go 8.1 kilometers at 20.8 degrees north of west. How far are you from your starting point at the end of your journey? Okay, so again, this is going to be, we're going to have two vectors. We have to take the sum of those vectors, and then the magnitude of that sum is our displacement, or that's how far we are away from the starting point, which is what we're being asked for this problem. Okay, so you're going to have something west of south and then something north of west, but your angles and the size of that walking path is going to be different for every one of you. So we have to pick somewhere to be our starting point. Here's my starting point. I drew in my cardinal points, north, south, east, west. So we want 55.4 degrees west of south. So we start from south, and we're 55.4 degrees west of that. Okay, so here's south. I'm 55.4 degrees west of that. So it's this angle right here, this angle theta, which is 55.4 degrees. That is west of south. Okay, and so we're going to call this vector, again, vector A. This is vector A. And then from right here, okay, we've got north, south, east, west. From here, we're going to go, oh, I'm going to say that vector A is also, we've got 8.1 kilometers. Now from here, we are going to go 20.8 degrees north of west. So I'm going to go over here to west, and then I'm going to go 20.8 degrees north of that. Okay, north of that. So this is my next vector. And then this angle here, this angle is, we'll also call it angle theta, is going to be 20.8 degrees. Okay, we're going to call this vector B, and then vector B is also, just so happens that this one's 8.1 kilometers, but you probably won't have the case that both of your vectors are going to be the same length. Just a coincidence. Okay, and then our displacement would be this vector right here. That one. I didn't quite draw it in just right, but this is my displacement vector that I'm going to be looking to solve for. Okay, so we have two vectors, A vector, B vector. We sum up A and B vector. That gives us D vector. We take the magnitude of D vector. That gives us our displacement. Okay, magnitude of our displacement. So let's start here by writing out our vectors in a vector form. Let's start with our A vector. Okay, so A vector right here, this is my A vector. It has a magnitude of 8.1 kilometers. Okay, now if I drew in a little right triangle here with legs for my A vector, this component would be the y component of my A vector. This component here is going to be the x component of my A vector. Now it's this angle up here, that's my angle theta that I was given. So in order to find out what AY would be, we can use cosine. So cosine theta, this is my angle theta, is equal to the adjacent side, which happens to be AY in this case, divided by the hypotenuse of this triangle, which would be the magnitude of vector A. So AY is equal to the magnitude of vector A cosine theta. Okay, and so then that would be equal to the magnitude of vector A is 8.1 kilometers times cosine of that angle, which is 55.4 degrees. Remember, keep your calculator in degree mode. And then we find that this magnitude is, let's see, AY cosine theta, 4.60 kilometers. Okay, but we have to be careful. In our previous problem, all the vectors were in the positive direction. But here we have to pay attention because we drew our vector off down in this direction here. That means that my y component for this vector is negative. So the magnitude of that y component is 4.6 kilometers, but it needs a negative sign on it because we have to go down in the minus y direction when we're moving in, along this path, okay? So AY is minus 4.6 kilometers. So AX, if AY was, we used cosine to find AY, we can use sine to find AX. So AX is going to be equal to the magnitude of A sine theta, okay? And so then that's going to be 8.1 kilometers times, oops, sine of 55.4 degrees. And so then that is also equal to 6.67 kilometers. But again, we had to go in the negative x direction here for this vector when we're going down in both the negative y and negative x. So this is actually minus 6.67 kilometers. So if I come back up here to my a vector and put in my components, ax is minus 6.67 kilometers in the x direction plus minus 4.60 kilometers in the y hat direction. Okay, so you could get rid of that plus sign there. It's just minus 4.6. Here we go. Okay. Now, for our b vector, we put the little vector signs on there. B vector is bx x hat plus by y hat. Okay. Now I'm going to come over here to my b vector. And again, I'm going to put in the legs of this little triangle here I can draw, where b vector here is the hypotenuse of that triangle. So this leg is my by leg. This leg is my bx leg. Okay. Now, here, it's this angle down here. That's the angle that's given to me. That's my angle, 20.8 degrees. Okay. Just because this first vector that I drew had ay equal magnitude of a cosine theta does not mean that by is going to be b times cosine theta. You have to pay attention to where your angle is and how you've drawn in your hypotenuse and the legs of that vector. So you have to treat each one of these vectors separately or differently. Okay, so since I have this angle right here, this angle is adjacent to bx. So I can say that cosine theta is equal to my adjacent side, that's bx, over the hypotenuse, which is the magnitude of b. So then bx is equal to the magnitude of b cosine theta. You see that bx, here we're using cosine theta, but for ax we use sine theta. Okay. So just pay attention, it's going to be different maybe for your vectors depending on how you've drawn them. Okay. So the magnitude of b was also 8.1 kilometers times cosine, this angle is 20.8 degrees, okay? And that's going to be minus 7.57 kilometers. So when you just do 8.1 times cosine 20.8, you're going to get a positive number. But if we think about the way in which we had to draw this vector, we had to go in the negative x direction when we're drawing this vector. Okay, so negative x direction towards the west, we have to give bx a negative sign on front of it. Okay, and so since with this b vector, since the x component used cosine, that means that our y component is going to be able to use sine. So by is going to be the magnitude of b sine theta. And you can always prove that to yourself. We go back up here to this angle. We see that the sine of theta is equal to opposite, which is our by side, over the hypotenuse, which is the magnitude of b. So then if you solve that for by is equal to the magnitude of b sine theta. That's what we just got right here. Okay? And so if I plug in 8.1 kilometers times sine of, this time our angle is 20.8 degrees, then by is 2.88 kilometers. Okay. By, though, is positive. So we are thinking about the way in which we drew our vector. The x component was negative, this direction, but the y component is positive, moving up, so it gets a positive value. So I come over here and I fill in my b vector. Bx was minus 7.57 kilometers, x hat, plus by, 2.88 kilometers, y hat. Okay? Now we can take the sum of these vectors. Okay? Sum of these vectors, our displacement vector, is going to be the sum of vector A plus vector B. Okay? And so then that's going to be equal to AX plus BX x hat plus AY plus BY y hat. Okay? So then this is going to be minus 6.67 kilometers plus negative 7.57 kilometers plus AY, minus 4.6 kilometers plus 2.88 kilometers. Okay, now that was in the x hat and this was in the y hat direction. Okay, now if I add minus 6.67 kilometers to minus 6.67 kilometers minus 7.57 kilometers, that is negative 14.2 kilometers in the x hat direction, plus we've got minus 4.6 kilometers plus 2.88 kilometers for the y hat direction. That's minus 1.72 kilometers for the y hat direction. Okay, so then my x component of the d vector, we could call that dx. The y component of my displacement vector, we can call that dy. So the magnitude of this displacement is going to be our Pythagorean theorem. It's going to be dx squared plus dy squared, the square root of all that. Okay, so then that equals the square root of minus 14.2 kilometers squared plus minus 1.72 kilometers squared. And that equals 14.3 kilometers. And that is the magnitude of my displacement from my starting point to my ending point. Okay.